Hello students, in the first lecture we understood the concept of rest, motion, different physical quantities like scalar quantities and vector quantities, as well as distance and displacement. So the next topic comes as speed. We have fair idea about speed studying in mathematics, that is speed, distance and time chapter. So what is speed? Speed is rate of change of distance. So what is rate? Whenever this term rate comes, we divide the physical quantity by time. So we can define speed as the distance traveled by a body per unit time over a short interval of time. So the formula becomes speed is equal to distance upon time. The SI unit, that is international standard unit is of distance is meter and time is second. So speed unit comes to be meter per second and it is a scalar quantity. The scalar means that it has only magnitude but not direction. So this unit can be meter per second, kilometer per hour and centimeter per second, but we try to keep it in meter per second only. Suppose you have to change kilometer per hour into meter per second. So what we'll do, we'll change kilometer into meter by multiplying by 1000 and seconds into hours into second by multiplying by 3600. So we get 5 upon 18. So if you multiply 5 by 18 to kilometer per hour, it will be changed to meter per second. Simultaneously, if we multiply 18 by 5 with meter per second, we'll change the meter per second into kilometer per hour. Suppose we have n number of speeds given. So before adding, what we'll do is we'll change all the units in meter per second or in kilometer per hour. We cannot add kilometer per hour into meter per second. What is average speed? So we can say that it is a ratio of total distance covered to total time taken. So again the unit will be meter per second. So the average speed of a moving object is equal to the ratio of total distance traveled by the body to the total time taken to cover that distance. Then there is one more, that is instantaneous speed. So instantaneous speed is basically, if suppose we are driving, at any point of time we are seeing the speed. That speed at that particular time is called as instantaneous speed. If we talk about the whole course of journey, suppose we are traveling from one place to another, so the whole time taken and the whole distance, if we divide or we get the ratio of distance and time, we get average speed. But in the due course of time, if we see at any particular time what is the speed of a car or a bike, so that is instantaneous speed. In last lecture we also speed uniform motion. Similarly, there are two types of speed, that is uniform speed and non-uniform speed. So if the body travels equal distance in equal interval of time irrespective of direction, then it is said to be having uniform speed. Why irrespective of direction? Because speed is a scalar quantity, and if we take direction, speed changes to velocity, and velocity is vector quantity. We will see velocity later. What is non-uniform speed? If the body is covering unequal distances in equal interval of time irrespective of direction. So again, if we want to find what is the distance traveled, so it is in case of non-uniform, it is average speed into time. And here also, if it is a uniform speed, we know that the speed is constant throughout the motion. Again, if we divide that uniform speed into time, we'll get the distance. But in non-uniform speed, we will always see the average speed. Why average speed? Because if we take instantaneous speed, at that instantaneous speed, the body may cover less or more distance. So we always consider average speed in case of non-uniform motion. The next topic is velocity. Like distance and displacement, distance was scalar quantity and velocity was vector quantity. Similarly, velocity is same as speed, but it has direction as well. So we can say that the speed of body in a particular direction is called as velocity, or the rate of change of displacement is called as velocity, or you can say that the displacement of a body per unit time over a short interval of time is called as velocity. Again, the unit is same as meter per second. We know that displacement and distance both have same unit, that is meter. Similarly, velocity and speed have same unit, that is meter per second, and velocity is a vector quantity. So what is the formula? Velocity is displacement upon time. Displacement unit meter and time is second, that is meter per second. Also, if you see that the note section, I've written that velocity of a body changes due to change in its speed and direction or both. So if a body is traveling in a certain direction with a speed, then that speed is its velocity. But if the direction changes, although the speed is not changing, now the velocity has changed, or you can say that it has a speed because the direction is not fixed. Every direction will have its own velocity, because we know that velocity is the vector quantity and it includes direction as well as magnitude. Again, uniform or constant velocity, when a body travels in a straight line in a particular direction and covers equal distances in equal interval of time. So we have written here in a particular direction. You could have also written that when a body travels in a straight line, we know that in a straight line, whenever we join 2 points with a straight line, that gives us displacement. So in uniform velocity, body travels in straight line in a particular direction and covers equal distances and equal interval of time. Whereas if the body is said to be have non-uniform velocity when it covers unequal distances in equal interval of times, or you can say that it covers equal distances in equal interval of time but the direction changes. So let us define once more. A body is said to have non-uniform velocity when it covers unequal distances in equal intervals of time or in a particular direction, or you can say that when it covers equal distance in equal interval of time but the direction is not same. So it will have non-uniform velocity. Why? Because the velocity is changing. Suppose we are talking about circular motion. Although the body may travel on a circular path with a constant speed, but in circle we know that at every point the direction is changing, therefore the velocity is changing, and because the velocity is changing, we will see different aspects in circular motion once we will cover that. The formula for average velocity is little bit different. It is not like the total distance upon total time taken. Here we take initial velocity plus final velocity and we divide by 2. Always remember that initial velocity is represented by u and final velocity is represented by v. So average velocity is u plus v upon 2. One very important point, that speed and velocity becomes identical during straight line motion in positive direction. Why we have written positive direction? I told you that vector has a particular direction. Suppose we are taking xy axis. If we have considered that right hand side is positive, that is any body that is moving towards right hand side, it is positive. So if the body is traveling in the right hand side, that is positive direction. So if the speed and velocity we take in that direction, then it is said that the speed and velocity is same. But if any body is traveling in left hand side direction, we will take minus sign, and that minus will tell us that the direction is opposite. So it is very easy via vector to understand whether the direction is same or different. If the direction will be same, both will have same sign, that is positive sign. And if the direction is different, one will have positive sign, then the other will have negative sign. So this condition is condition 1, magnitude of average velocity is equal to average speed. So if anyone asks what is the condition when magnitude of average velocity is equal to average speed, you will say that its speed and velocity becomes identical during the straight line motion in positive direction. Let us take an example by a question. So the question is, Joseph jogs from A to B and the distance between A to B is 300 meter in 2 minutes and 30 seconds, and then turn around and jogs back 100 meter back to point C in 1 minute. Calculate the total distance, total displacement, average speed and velocity in A to B and motion from A to C. So we can draw the figure like this. From A to B the distance is 300 meter and from B to C it is 100 meter. So it is very easy to get the total distance. What will be total distance? We know distance is the total path covered. So total path is A to B and then B to C. So it becomes AB plus BC, that is 300 plus 100 meter, that is 400 meter. Whereas in case of displacement, what is displacement? The shortest distance between 2 points. So the initial position was A and the final position is C. So if we join A to C, it will give us displacement. So what is AC? AC is basically AB minus BC. AB is 300 meter and BC is 100 meters. So the displacement comes 300 minus 100, that is equal to 200 meter. Now if we talk about section AB, what would be the average speed and average velocity? So we know that section AB, the total distance that is covered is 300 meter and the time that was taken was 2 minutes and 30 seconds. So that becomes 150 seconds. So average speed is total distance upon total time taken, that is 300 upon 150, that is 2 meter per second. And because it is a straight line motion, and we have studied earlier only that if we take positive direction, then the speed is same as the velocity. So average velocity in the case of AB is same, because in case of AB the net displacement is from A to B and the displacement is also 300 meter and the time taken is 150 seconds. So average velocity AB is equal to average velocity or average speed AB, that is 2 meter per second. As soon we go to section AC, now the distance and displacement changes. From moving to point A to C, the path covered was from A to B and then B to C. So total distance covered was 400 meter and the total time that was taken was 2 minutes 30 seconds plus 1 minute, that is 210 seconds. So average speed is equal to total distance upon total time, that is 400 upon 210 seconds, that is 1.9 meter per second. And the net displacement that was there is now 200 meter. So the velocity becomes again displacement upon time, that is 200 upon 210, that is 0.95 meter per second. So here we have observed that the velocity is different from that of speed, whereas in the section AB case the velocity was same as that of speed. Why? Because there the direction was not changing, so we took that average velocity in positive direction is same is equal to that of average speed. But here the direction change, A to B and then B to C. So there was net effect in displacement and that of distance, and thus the result was different. So I would request you all to practice more numericals from your books, and we'll continue with the numericals and other topics like acceleration, and we'll in the next lecture. Till then, thank you.